You are welcome again to our class. Today we'll be quickly looking at a vertical motion question on motion. The question goes thus. As you can see it on your screen, a body of mass 5 kg is projected vertically upward. Calculate its potential energy at the maximum height if it attains 20 meters per second at a height of 4 meters. So let's take note of the parameters. We can already see it on the screen. As we can see that we have 5 kg mass. The initial velocity, decided to call this value the initial velocity because we are still looking for the velocity. We can still look for the velocity at the maximum height. And because we also asked to look for the potential energy at the maximum height. So you can say the velocity given relative to the velocity at the maximum height is the initial velocity. Now, the height we are given also is 4 meters relative to the maximum height, which we don't know. So there are two ways to go about this work. You can either use the approach of equations of motion or use the approach of conservation of energy. And according to the thermodynamics first law, it says energy at all points in motion like this is constant. If you want to state it properly, it says energy can neither be created nor destroyed, but can be converted from one form to another. So it means that the total energy, if you call this point A, and we call this point, let's call it point B, and the point of maximum height, we call it point C. It means that at point C, which is the starting point, the body has only kinetic energy. Why kinetic energy alone? Since it has not attained any height. For it to have potential energy, it must have attained a particular height. Because the formula of potential energy is mgh. Potential energy is directly proportional to height. Both mass and acceleration due to gravity are constant. So at point A, there's no height. It has only velocity. That is the velocity with which we used to project it, which we don't know, we were not given. But we are given the velocity that it attained, which is 20 meters per second at the height of 4 meters. So you can say at point B, it has both kinetic energy and potential energy. How do we get there? Kinetic energy because of 20 meters per second speed, and potential energy because it has attained the height of what? 4 meters. Now, at the maximum height, which is point C, the object has only height, this h maximum. It does not have velocity again. The maximum height velocity is 0. So we can see object here has kinetic energy, which will be maximum, the highest form. As it goes up, the kinetic energy is decreasing, the potential energy is increasing. Kinetic energy is decreasing, it decreased to 20, and eventually the speed decreased to 20 and eventually decreased to 0. So the kinetic energy is decreasing. The potential energy was 0 here. Then it started increasing as the height increased to 4 meters, and it has a particular maximum height potential energy, which we have been asked to calculate. So I hope you've understood the question. So let's go about it. What we have to recollect is that kinetic energy as well has a formula which is half mv squared. Now, the total energy that the body possesses, we said is constant, is unchanging. The total energy at point A is constant. The total energy at point B is constant. Total energy at point C. What do you mean by that? It means that the energy, the kinetic energy at point A must be equal to the two energies that we have here. Kinetic energy of B plus potential energy of B. And they also must be equal to the potential energy at maximum height. Hope I have not complicated the matter. That is, the total energy here must be the same as the total energy at this point, and must be the same as total energy. Energy is constant. When it's energy is conserved, it means that it is constant. It is not changing. The kinetic and potential energy may be changing, but the sum total of all the energy is always the same. It's constant. So let's try to understand. So it means that the potential energy at the maximum height will be equal to these two. As we can see, it will be equal to the kinetic energy at B and the potential energy at B. Hope we understand. So let's solve it. So what's the kinetic energy at B? It's half mv squared. Let's write the formula again. Half. What's the mass? The mass is unchanging. It's 5. What's the velocity at B? What's that velocity at B? 20. So that's 20 squared. That's 1 over 2 times 5 times 400. That's 1 over 2. 2 here 1, 2 here 400 is 200. And that will give us what? 5 times 2. That's 1,000 joules. That's the kinetic energy at B. That was 1000 joules. That's kinetic energy at B. Now, the potential energy at B is mgh. That's the formula. Mass times acceleration due to gravity times height. So our mass is still the same. 5 times acceleration due to gravity. Let's take it as 10 times height. What's the height at B? That's 4 meters. 5 times 4, that's 50 times 4. That's 200 joules. Potential energy at B. Therefore, the potential energy at the maximum height, to be sum total, what we had here before, because the potential energy at maximum height is never the same as that of this. The potential energy will be higher. This one is smaller. Take note. So it will be what? 1000 plus 200. And that gives us what? 1200 joules. I hope you understand. I'll be treating the second method by which you can solve it in the next slide. Thank you.